Hi, this is Nathan Tintle. In this Learning Goal video, we're going to discuss how to approximate a 95% confidence interval by using the 2SD method. We'll use the Affordable Care Act data to talk about this learning goal. One way to find a confidence interval is to test many different null hypothesis values of the unknown parameter. In this table, we show you the results of running tests of the null hypothesis of 0.659 or 0.66 or 0.661 or all the way up into the 71%. And what we end up with is a set of plausible values for the parameter. That is, a set of values that if we tested them as the null hypothesis, we could not reject. We say those values are plausible values for the unknown parameter. In this case, the unknown parameter is the proportion of all U.S. adults who say that the Affordable Care Act has had no effect on them or their family. This is a tedious process. There's lots and lots of tests to run, whether with sort of simulation or theory-based approaches. But there is a shortcut. We're going to talk about that now. Here's the key idea to the shortcut. When a null distribution is bell-shaped, which is what happens here, about 95% of the statistics will fall within 2 standard deviations of the mean, with the other 5% outside of this region. So if we simulate a null hypothesis, the simulated statistics here would be sample proportions. We expect about 95% of those sample proportions to fall within 2 standard deviations of the mean. It's for this reason that the 95% confidence interval can be approximated as the observed statistic plus or minus 2 standard deviations, where the standard deviation is the standard deviation of sample proportions. Let's look at a specific example here. If our null distribution shows a standard deviation of proportions of 0.016, then the confidence interval can be approximated as 0.69 plus or minus 2 times the standard deviation of the sample proportions. That's the 0.016. This gives us an approximate 95% confidence interval from 0.658 to 0.722. Couple of words of caution on this approach. First, it does require simulating to get a standard deviation of the statistics. When you do those simulations using a null hypothesis value of 0.5 is the most conservative choice. At the end of the day, this approach should be considered a quick and dirty way to get a rough approximation of a 95% confidence interval. There are more precise intervals out there, and as well the ability to get other confidence levels, so 99% confidence or 90% confidence, using other approaches, specifically a theory-based approach. Now that comes with its own baggage called validity conditions. We'll talk about that in another Learning Goal video.